Okay, guys, last time we finished up discussing the Wilson cycle, and this is the cycle of how our continents change over time. An important concept, okay? But what I'm going to do here is there's a great video. If you go into the, you can get it from this link if you want to. If you click on this, you can actually watch this video. But a better thing to do is to actually go into Canvas, and in the lecture slides at the bottom, there's those additional material. This link is there, and you can watch that link. And I can't do it on these video slides because of the limitations of the screencast. But you can go click on that link in the lecture slides. And I'll try to put a link to it underneath this lecture to help you remember to click on that. This will be a great example of how this Wilson cycle works as North America broke up from Pangea. Now I'm going to go through this as well real quick. I have a slideshow that it shows this really well, so I'm going to show that to you in just a second here. So I'm going to pause here for a bit, and when we see you again, we'll see you in a different slideshow. Okay, I'm back. This time I'm in a slideshow that you can see it from your Canvas as well. I included this slideshow in your material, and I think if I remember right, it's called the Tectonics of North America and of Eastern North America. And so what I'm going to do is I'm going to actually go through the tectonics of Eastern North America really quickly. And we're going to start all the way back to about 1.2 billion years ago. And this is a time period that we call the Precambrian. If you look, and so this is so long ago that North America and Africa were actually together, and it's in the time frame that we call Rodinia, or where the continents were together as one big continent we call Rodinia. This is prior to Pangea. Okay, so the continents have been together multiple times in the past. It's actually up to 3 different times in the past. But Rodinia is one that occurred about 1.2 billion years ago. And then about 750 million years ago, it started to separate and pull apart. This is a lot like the first part of the Wilson cycle, right? Where the continental crust, what we call a divergent continental boundary, starts to form. And as it starts to form, it starts pulling it apart, right? Forming a divergent plate boundary when you have 2 oceanic crusts. Nope, because now it's an oceanic divergent boundary. Now it's going to be pulling apart, pulling apart, pulling apart until Africa is further away. So let's keep bringing this on. This is now North America 550 million years ago. As you'll notice, here is North America, here is Africa, and South America is actually with Africa at this time. Okay. Now notice here, North Carolina, there is no North Carolina. The only part of North Carolina is right up here in the mountains. And that's where some of the oldest rocks in North Carolina lie. It's right there up in the Appalachians, near Boone and Asheville and all those areas there. That is where the age of those rocks. It's about 1.2 billion years ago to about 750, 800 million years ago. Okay. Now also notice something. This line right here is what we call the equator. The continent is actually on its side. Okay, and it's on its side and up here, it's below in the southern hemisphere at this point. Okay, now how do we know that? Well, we know that from a lot of different things. We can know it from the actual rocks, the sedimentary rocks from the clues that we see there. We know that from the volcanics and the magnetism of those rocks. There's lots of different clues that tell us that this is where they were. Okay, now what you'll notice here is over time is that the continent actually rotates over time and goes to the north, above the northern hemisphere where we are right today, right? But back then it was actually much warmer at this time frame, so the rocks that we see are more tropical rocks that would form in these kind of basins. Now you'll see here on the left here, this is what you'll see is the periodic table, not the periodic table, sorry about that. Okay, this is our geological time scale, where you'll see the different times in which the Earth, the ages that you have. Right now we're at about 550 million years old. You see that right here. And then this is temperature going up here. Where it's on this side of the line, that means it's warmer than it is for our average temperature today. This line in the middle is our average temperature today. So in places where it's red, that means the world was warmer during that time frame than average. And then the places that it has blue means that it's colder than average. So notice these places where the temperatures dropped, those are cold spells. We call them lots of times these ice ages. And yes, we are currently in an ice age. We are not above the normal average of the world today. Now we have lately, but we'll talk about that later. Okay. So the point comes is that most of our planet was actually much warmer than it is today. But we didn't live in that warm time frame, so that's an important thing to understand. What's going on over here is sea level. Sea level goes up and down, and sea level goes up and down for many reasons. Some of it is that the water gets displaced as the divergent boundaries push up the crust. Other ones might be that there's glaciers on the planet, and therefore the oceans shrink because there's all the water in the oceans are now on land, or all the glaciers melt, so therefore all the water is in the oceans. And so so sea level can go up and down over time, and that's what these are here, is this different sea level changes. And we'll see that as we go through this. Okay, so here we go. Here's North America. There's Africa and South America. Here's Europe. And as I click forward, this is now 510 million years ago. Now notice where Africa and South America is. They're moving away. So this is that divergent plate boundary in the middle, pushing things apart. What you also notice, though, is there's actually a convergent boundary here where you're forming an island arc, where the oceanic crust is going down and actually melting, forming islands on the other side to form what we call a continental crust. So this is how continental crust is formed. Continental crust is formed when two oceanic plates come together to form more material from the mantle and moves it upwards. Okay, so notice that these islands are actually will at some point become part of North Carolina. So this is North Carolina out here. And some of the igneous rocks that you guys saw last time actually came from island arcs just like these. Okay, so let's keep going. This is 510 million years ago. Notice that Africa and Eurasia moved further away. We are moving further to the north. Sea level is rising. These islands are actually moving closer. Notice that before, this island was actually above water. Now that sea levels rose, most of it's underwater. Okay, keep moving. Again, those islands are coming closer to the edge of the continent. Keep coming closer to the edge of the continent. Notice that Eurasia is coming closer to us as well. Okay, so what used to be going apart is now coming back together. Cool, huh? And sea level's high. When sea level's high, these areas are there inundated. The whole continent here is pretty much inundated by the ocean because the sea level is higher. And notice what's happening here is these islands are now slamming into the coast. And as they do so, they make mountains. As they make those mountains, these are the old ancestral Appalachians. Okay, and then you keep going, and here comes Eurasia slamming into North America, making this big mountain range here. Okay, now this is your ancestral Appalachians once again starting to form over time. Notice as well on the west coast you're having islands coming in as well, because notice that there is no California over here either. Okay, and you keep coming in. Here's some more island marks slamming into the coast. Now we have Africa and South America down here is coming closer as well. Keep coming, and now they've bridged the gap, causing this big mountain range, just like the India today and Mount Everest. And yes, the Appalachians used to be probably about as tall as Everest is today. But since then, they've been slowly eroding away. Now notice it keeps going slamming together, and then slowly the mountains are actually eroding away, becoming smaller and smaller over time. This is millions of years, guys. It takes a long time for this to happen. Now, as I keep pulling away, notice that there's now starting to pull apart again. So now it's pulling apart. This is your divergent continental boundary, just like the East African Ridge today. Okay, pulling apart, forming these linear basins, a lot like East Africa today. Okay, keep going, and now it's fully apart. Okay, so this is kind of like the Red Sea today, where it's been pulled apart. Now you have the ocean can come in and start moving apart. Also notice that it starts to tear apart down here. So now you have Africa and South America being pulled apart as well. Okay, this is what we call a triple junction, where three parts of it, or divergent boundaries, are coming together to slowly rip around the other material. Sorry about that, my alarm went off. Okay, this keeps pulling apart. This is the Mid-Atlantic Ridge here. It starts to develop. In the western United States, we still have more and more of these islands slamming into the coast. Keeps going to form California and everything today. This is still the sea level is a lot higher, therefore the internal portions of the Atlantic, the ocean, the continent are actually underwater here. And then we keep going. This, by the way, is where a lot of our oil that we find in these regions actually was formed.
You keep going, and by the way, then we have 65 million years ago. This is when the dinosaurs pretty much died out. Okay, a big meteorite impact hit the Yucatan Peninsula below. We're not going to get into that today, but killed most of the dinosaurs. Okay, so this is what North America would have looked like during that time frame. Here's a mid-ocean ridge out here. Notice there's one also out here. Keep going, and here comes this mid-ocean ridge inward. Okay, slams into the coast. The divergent plate boundary does, pulling apart the coast down here, forming the Baja California and forming the San Andreas Fault. Okay. And then you have my favorite time frame, because this is when I do a lot of my geological studies, which is the last ice age, about 18,000 years ago. Okay, and then you have modern today. Okay, pretty cool. So that kind of